Once you have an ellipse in standard form, once it's in this nice x squared over something plus y squared over something equals 1 standard form, it's pretty easy to graph. First thing you're going to do is you're going to graph the center. Center is going to be 2, negative 1. I go to 2, negative 1, and I put a dot. Then I graph the vertices and co-vertices. I find those by moving in the x and y direction, the amount that I get from the numbers under x and y. I'll explain what I mean. 25 is 5 squared. In the x direction, I'm going to move 5 units from the center. I'm going to move 5 to the right and 5 to the left. Similarly with y, 9 is 3 squared, so I'm going to move 3 in the y direction. I'm going to move 3 up and 3 down. With those vertices and co-vertices, and later I'll point out which is which, I'm ready to graph my ellipse. I'm just going to connect them in an oval-like fashion and do the best I can to make it look elliptical. The trick to ellipses is not to get too jealous of how good I am at drawing them. It's hard. I'm very good at it. I'm better than you is what I'm saying. After these, I'm going to draw my focus. My focus I'm going to find by first finding the focal length using the not Pythagorean theorem. I'm going to find the focal length using a squared minus b squared equals c squared, which looks a lot like the Pythagorean theorem, but isn't. A squared and b squared are the numbers in the denominators. A squared is the bigger one, b squared is the smaller one. A is 5, b is 3, but that doesn't matter. A squared and b squared are already there. I could just not even know that it's 5 and 3 squared. A squared is 25, minus b squared is 9, equals c squared. 25 minus 9 is 16, equals c squared. So c must be 4. My focal length is 4. From the center to either focus is going to be 4 units. Because this is a wide ellipse, not a tall ellipse, because it's bigger in the x and y, the x direction than it is in the y direction, I'm going to move left and right to get to 4. Because this is a wide ellipse, I move left and right. I move left 4, 1, 2, 3, 4. Right 4, 1, 2, 3, 4. Those are going to be my foci, or focuses, or foci. All of those are correct. Anyone who says differently is wrong. That's my ellipse. If you want to know, probably a question that says graph it probably also wants to know coordinates. So I'll fill those in. The center, we said, was at 2, negative 1. The dark blue points we've got by going 5 to the left and 5 to the right. So if I start at my center and I go 5 to the left, that means take away 5 from x. Taking away 5 from 2 means negative 3, negative 1. To the right, I add 5 to x. Going up by 3, I reach the point 2, 2. Down, I reach a 2, negative 4. The focuses I got by moving 4 left and right, so adding and subtracting 4 to the x. Those are my vertices, co-vertices, focuses, and my center. I didn't point out which one are the vertices and co-vertices. This line connecting these two and this line, sorry about that. I'm not going to redo this video just for that. This line, those are axes. One's the major axis, one's the minor axis. The major axis is the bigger one. The major axis is this one. The tips of the major axis are my vertices. The lighter blue line, the smaller axis, the smallest diameter, is the minor axis. And the tips of my minor axis are my covertices. This doesn't have to do with graphing, but while I'm at it, the easiest mistake is if a question says how long is the major axis. For this problem, for instance, if it said how long is the major axis, the easiest mistake to make would be to say 5. You look at the major axis and you say, oh, the major axis came from this number, which meant I moved 5, so the major axis must be 5. The major axis is the whole diameter. The major radius is 5. Major radius is 5, which means this whole thing is 10. Same with minor axis. The minor radius is 3, so the minor axis is 6. I think that is all. I apologize for the quality of this microphone. I'm using my laptop's microphone because I don't have one for my smartboard yet.